All right, guys, so we're going to do application problems from 7-7. So these are going to involve both growth and decay. And what I have at the top for you is just a little bit of a quick warm-up. So if you want to try those, if you click on the supplemental notes for today, after this video, you'll see the answers to them as well. So if you wanted to try that, just a quick reminder what growth will look like, what exponential decay will look like, and practice writing those functions given the table. So definitely something that you want to check out. But for today, our focus is going to be on these application problems. So we're going to take a look at a general formula that you're going to use over and over and over again. So that should be pretty comforting. A formula that's going to be given to you for your test. So you'll have that. Not only will you have it on your papers at home, but it'll be on the actual Google form, so you'll have that. But it essentially takes these growth and decay problems and gives them real meaning. So that should hopefully be very helpful for you because it's very applicable. We talked a little bit in the penny or check activity video about, everything that's going on right now with COVID-19 is very much relates to exponential growth. And there's a lot of stuff out there. If you're interested in it, wouldn't upset you, would be really cool to check it out and really see how, knowledge of exponential growths can really help you to understand the numbers a little bit better. So first thing I'm going to do is just give you that formula, kind of identify all the pieces, and then we'll start practicing where we put those values in. This number, sometimes it's represented with a C, an A, a P. It shouldn't really matter what letter is in there. I think on the formula that I provide you with on the test, there's an A. It shouldn't really matter. It's whatever your initial amount is. So that number out in front is just your initial amount. This is always a 1. If it's growth, it's a plus, okay? R, just your value R, is your growth rate, the rate at which it's growing. So when you combine that with the 1, this entire value, this 1 plus R, is known as your growth factor. And T is pretty simple because it represents time. So my suggestion to you is that as you read through the problem, you identify what is C, what is R, what is T, and then we build it in, and then I'll kind of walk you through typing it in and stuff. But we have 3 examples of growth, and then we'll do 3 examples of decay. All right, so your family bought a house for $150,000. That is an initial amount. That's how much they purchased it for. That is my C value, so I'm going to identify that. This method of kind of like outlining the variables that you know and what you don't know, right? It's a very helpful thing, especially as you move into more mathematical based sciences the next couple of years. So I highly suggest that you don't just kind of roll your eyes at me and she won't know, she can't see me, but it's a great habit to create, is listing out what you have and then putting it in. If you're trying to find those things as you're putting them in, it lends itself to more mistakes. Okay, the value of the house increases at an annual rate of 8%. So here's the tricky part with R, okay? A percentage can't be entered in as 8%, can't be entered in with the percent sign. So when you enter in your R value, you have to absorb the fact that it's a percentage. What does that mean? It means you have to move the decimal point. So if it's 8%, what that actually translates to is 0.08, okay? When you're talking percentages, 0.08 is 8%. You can't put it into the formula with the percent sign. That's not gonna do anything. So I have to tell the calculator what this value is. And because it's 8%, I have to write it this way so the calculator understands it's 8%. That's the only tricky part that I really find to this section is how you write your rate. But again, you're going to have so many practice problems. What is the value of the house after 5 years? So the time is 5. So let's try this. I have my C value, which I wrote already on the side. 1 plus 0.08, not 8, not 1 plus 8, okay? So think about it. It's the reason that it's like that. It's how much more is it than 100%. That's why there's a 1 there. That's 100%. And I'm raising that to the 5th. So let me show you how I would type this into the calculator. I would start by adding my 1 plus 0.08. Then I would raise that to the 5th power. Then I would multiply that by 150,000. Now, you want to think about your answer as well. You want to think about whether or not it makes sense. This is money. I should be going to 2 decimal places because it's money. So that makes sense. I'm not going to round to the nearest dollar. I'm going to go to the hundredths place. This is how I talk about money. This is how everybody talks about money. I'm going to put a comma after the first three values, right? This is a money amount. Should it have gotten bigger? Yes, right? It says that the house increases at a rate of 8%. 8% is not a lot. Think about if you got an 8% on a test, right? You'd be really upset, right? So should the number be changing dramatically after 5 years? No, it should be growing, but it shouldn't be growing an outrageous amount because 8% is fairly small. So there's a lot of things you have to think about when you think about whether or not your answer makes sense. A lot of factors come into play. What is your rate? How much time has gone by? And really, how much did you start with? Although if you're comparing your final answer to what you started with, then that really isn't a factor. Let's try some more. The owner of an original copy of a 1938 comic book sold it at an auction in 2005. The owner bought the comic book for $55. That's my initial amount, is $55. The value of the comic book has increased at a rate of 2.8%. 2.8. How am I going to write that? Am I going to write it as 2.8? No. I need to take 2.8 and I need to move that decimal place to the left. If you need help on the calculator, you can always take your rate and divide it by 100. So if you are afraid that you're going to make a mistake, if you aren't sure how to convert and write that R value, divide it by 100 on your calculator will tell you. Take your R that's in the problem, 2.8, divide it by 100. Oh, 0.028 is what I need to put in my formula. Got it. Now this one's kind of tricky because it gives you a lot of years and it gives you this 1938 to throw you off. That one's irrelevant. It was purchased, it was $55 in 1980, and now we're talking 2005. How many years have gone by? 25 years. So I'm ready to plug in. 55, 1 plus my 0.028, right? To the 25th. How should I type this in? Add your 1 plus R first. Raise it to the exponent, multiply it by your initial amount. I'm doing PEMDAS every time I do these problems. You see how important it is that you remember PEMDAS? I have to do parentheses first, then exponent, then multiply, P-E-M. Can't multiply before you apply the exponent. Can't apply the exponent before you've simplified up what's in the parentheses. So I get 109.70 if I round properly to the hundredths place. So $109.70. Now again, 2.8%, very, very small, but 25 years have gone by. So it probably should be worth a lot more, right? Maybe about double. Let's try one more growth problem and then we'll move on to decay. So let's see. I have a newly hatched catfish. Here's its weight. During the first 6 weeks of life, The growth rate is exponential, increasing at 10% each day. Write a model to find the weight at the end of 6 weeks. Okay. So what's interesting about this one, right, is that it's confusing because of the timeline, right? I have things about, first of all, I have a weight, which is in grams, but that's fine. That shouldn't really be an issue. So far, we've been doing things in dollars, but that's okay. My rate is 10%, so that's fine. So remember, if you want to convert your rate, it's 10% divided by 100 gives you the decimal version of your rate. So this would be 0.1, 0.10 if you want it to look like 10. The problem is that rate is a daily rate. So that makes this one a little tricky. And something we didn't necessarily talk about on the first page was your rate and your time have to agree. So if you're talking about a rate that changes daily, then what you plug in for time has to be days. But it wants to know, it gives me a time as 6 weeks. So what can I do if my rate is in days, but my time is in weeks? I have to convert one of them. So how many days are in 6 weeks? 6 weeks is the same as 42 days because there are 7 days in a week. That's the number that I have to use. So just try to keep that in mind. And for the most part, this will be true for every problem that you do. And, I don't want to trick you. This is definitely like the next level. It really separates those of us that know what we're doing from those of us who are just kind of getting by. But you should know how to do a problem like this, and you should understand that your rate and your time, the units of those have to match. So if my rate says each day, whatever I plug in for t has to be a number of days. So let's see, I'm going to have my 0.3, 1 plus, that's always the same. My 0.10 is 10%, but I'm raising it to the 42nd power because my 10% is a daily rate, so I have to plug in days. So let's see, add my 1 plus my rate, raise it to my time, multiply it by my initial value. So I get 16.43 grams. That's growth. Decay looks very similar. I still have my initial value, goes out in front. I still have a rate. This time it's a decay rate. Notice the difference. I still have time. What's different? Look at that minus sign. Because it's decay, it's now a minus. This is my decay factor. So instead of adding your rate to 1, you're going to subtract your rate from 1. That is the only difference for decay. Population starts out at 90,000. That's my initial value. My rate, look, decreases. That's the key that this is decay. That's the only thing that's going to trigger me to say, oh, I guess I have to do 1 minus. It's not going to say, here are all the decay problems, here are all the growth problems. They're going to be mixed up. You need to be able to identify one from the other. My rate, notice it's a 2.5%. So if I divide that by 100, I get 0.025. And it says that's a per year rate, and it says after 7 years. So my units agree. So here I go. 90,000, 1 minus, because it's decay, because it says decreases. My rate, convert it properly to the 7th. How do I type this in? Do your 1 minus your rate first, raise it to your power, multiply it by your initial amount. Should my value be smaller? Oh, it's not money, it's just a population. Should my number be smaller? Yes, it's saying the population decreases. So it absolutely should be smaller. Also, I'm probably rounding to the nearest whole number because it's a population. Okay, that'll probably be indicated in the problem. But for money, we rounded 2 decimal places because it's money. Anything involving people, we would round to a whole number. Let's try two more decay ones. In 03, family buys a boat. Initial value of the boat is $4,000. The boat depreciates. Wasn't sure if you knew what that word means. You could probably put two and two together, no pun intended. But depreciates means decreases, right? It doesn't appreciate, it depreciates because the value is going to go down as time goes on. It's like a car, right? Houses become more valuable. Cars depreciate the minute you drive them off the lot. That's the famous line. Okay, so just in case you see that word depreciate, you know what it means now. It kind of looks like decreases, so hopefully that's easy peasy. At a rate of 7% annually. So remember, 7%. I'm not going to plug that in as a 7. Okay, if I need the calculator to help me, 7 divided by 100, 0.07. Now it says they bought it in 03 and they want to know 06. So the time that goes by is 3 years. I'm ready to plug in. My initial value is 4,000. 1 minus my rate. This is decay, depreciate. Do your 1 minus first. Raise it to the power. Multiply it by your initial value. That's your PEMDAS in action. Should my number go down? Yes. Should I be rounding to the hundredths place? Yes, it's money. So in 3 years, the boat is now only worth about $3,200. Okay, last one. Scientists study the population of species from 83 to 03. In 83, there were this many. It decreases by about 11% annually. How much time goes by from 83 to 03? 20 years. Initial amount, 1 minus my rate because it's decrease, it's decay. Type that value in first. Raise it to your time. Multiply it by your initial value. The number should go down. We're talking about a certain number of bats, so we should probably round to the nearest whole number. And it actually drops quite a bit, right? 11% is kind of large when you're talking about all the numbers we've had so far, and it's over 20 years. So it should be a pretty significant drop.